My name is Florian Kohn. I'm working at the University of Hohenheim in Stuttgart, Germany, and I'm a postdoc in the Institute of Physiology in the Department of Membrane Physiology. My focus area is researching how the human neuronal system reacts to microgravity conditions. So the main goal of our experiments is to better understand how the human neuronal system reacts to microgravity research. When we send astronauts to space, we know that they behave differently than on Earth, and we just want to know how the molecular principles are changed. My experiment is funded by the German Aerospace Center, but we are also performing experiments with the European Space Agency. Usually we are doing these experiments in the European parabolic flight plane, which is located in Bordeaux in France. It's a special plane operated by the European Space Agency, and there real microgravity is produced and we can perform our experiments in real microgravity. We are looking for how single neuronal cells adapt to changed gravity conditions. And in a parabolic flight we have microgravity and we also have hypergravity, so we can directly compare these two states. We are looking for changes in the biophysical properties of these cells, either electrical changes, or what we are looking right now is changes in the membrane viscosity. Changes of the biophysical properties of these cells really has an effect on the nervous system. When you measure the nerve speed, for example, in the arm of astronauts, it's getting slower under microgravity. And we also found these changes on the cellular level, and now we're looking into detail into the subcellular level to better understand why is the speed changed. For microgravity research there are a lot of safety regulations, and also safety regulations which you don't encounter in a standard lab. And when we decided to do plate reader experiments under microgravity, we really had to find an instrument which enabled us to comply to these safety regulations. Finally, we choose the PHERAstar because it really fit nicely into these safety regulations, and the engineers were also on our side concerning changes in the software and modifications of the hardware which were necessary for our experiments. The key features for us was, first of all, the speed of the system. It's extremely fast, which is important for us because in a parabolic flight we only have 22 seconds of microgravity, and we need to do as many experiments in that time. And secondly, the modularity, so we can exchange the optical modules fast when we want to change our experiments. And of course, the size of the PHERAstar. We have to implement these hardware systems in a special containment, and there the size and the weight is a very important feature. When we approached BMG and explained them what we want to do, the engineers were really interested in that, and also the software engineers, because from our experiences, we had some modifications which we wanted to implement, which makes the work under microgravity easier, because under microgravity a plate can float away, so we need some sort of attachment system, something like that. And also the implementation of a gravity sensor was important for us. And of course the software should be easily accessible, and it's a brilliant system for us. In the future, I hope to achieve to better understand how the cells react to microgravity conditions, but I'm also using the microgravity as a tool to better understand the reaction of neuronal cells even here on Earth. For example, we found that the membrane viscosity is changed under microgravity, and this has a huge impact how, for example, pharmaceutical substances get into a cell. And I think this is a very interesting part perhaps for future design of medication, and I want to follow up this path.